So 2.3, number 2. The usual toll charge to use the Bingham Tunnel is 50 cents. If you purchase a special sticker for $5.50, toll is only 35 cents. At least how many trips to the tunnel are needed before the sticker costs less than paying for each trip separately? Good question. This is like when you buy like a ski lift ticket. Who goes skiing here? Anybody? You buy a ticket for the season, right? And it's like $320 or $350 for the whole season. But every lift ticket will be like $75. So you say to yourself, well, if I go 4 times, I'll make up for it, right? I'll make up for the money that I'm saving. It's worth it. But if I want to go twice this season, and I spent $350 on a lift ticket for the whole season, and it was only $75 per time, you're wasting $200 there. It's not worth it. That's what this problem is. So we got 50 cents a toll. Okay, that's our normal rate. And then we're told, if you purchase a sticker for $5.50, that yields a toll charge of only 35 cents. But what's the deal here? You don't just save 15 cents every time, you gotta pay this initial charge, right? So we want to know, when is this going to make sense? When are these going to be values equal to each other? We're really looking at like, say again?
I forgot to put the decimals.
Oh, so you did it with 50 and 35, and then you used 5.5 here?
Yes.
Had you forgot these decimals, you could have used 550 here, and that works. But you get the problem after that?
Yeah.
Do others want me to finish this? Yeah, I'm going to go through it, okay? So we want to know, every time you go through a toll, after how many times going through the toll is this going to be worthwhile? So let's call the number of times through a toll what? X, or some variable. So we want to know when the cost for here is going to be less than the cost for the second condition, right? We want the second condition to be worthwhile. So if we go through a toll X times, number of toll passings, or number of times we go pass through the toll, then if it's 50 cents per toll, it looks like this. That's what the cost would be. So if you went 30 times, you take 50 cents times 30, and that's the cost it would be after 30 times going through the toll. But if you go through the toll this way, it's 35 cents per toll, but you have to pay an initial $5.50. Everybody see what we're doing so far? The left-hand side is without the sticker. The right-hand side is paying $5.50 for the sticker, but it's only 35 cents per toll. Which of these do we want to be bigger? Which number do we want to be bigger? What does the problem say? Yeah, the 0.50x, yeah. So we make it look like this. When will purchasing the sticker, the right-hand side, be less than not purchasing the sticker? After how many trips is it worthwhile to purchase the sticker? Okay, to purchase the sticker. So Dave, what do I do to solve this? Alright, so let's move it over. What do you get? Should we make everything numbers to make it easier? Let's do that to make it easier. So what do you have? Give me the numbers, Dave.
50x is greater than 35x plus 550.
Yeah, this might make it easier on people. If you don't mind the decimals, stay with decimals. I know it's fine. It doesn't matter. But if you want to make it the whole numbers, it makes it easier, that's cool. Either way. Continue.
Then it would be 15x is greater than 550. And then if you solve it, it's like 36.66, which you can round it up to 37. And so that it would be at least 37 shares.
Okay. Others agree? Did you check the math, right? At 37 trips, right? At 37 trips, you'll save 5 cents, Dave is saying. But for every trip additional, you're going to save another 15 cents. So this is your break-even point. What does a break-even point mean? It means that both of these conditions would be about the same at this point. But after every trip additional, so if you go to this tunnel every day for work, it's definitely worthwhile, right? Because in a year, you work at least like, as an adult, a lot of days. We're talking like 250 days a year. That's what you end up working in most jobs. So 250 trips, well that means that there's 160 some odd, 63 trips now. I'm sorry, not 106, 213 trips left that you'll save 15 cents every one of those trips. So it will be a good savings in the long run. Sorry, Nate.
So I got like
4.
four trips.
Did you have the exact same?
No, but yeah, it started off the exact same, and then I
Subtracted this. 0.15x greater than 5.5.
Yeah, and then
And divide by 0.15.
I
Got
divided by
15. You good?
Yeah, sorry.
Okay. Let's keep going. Let's keep going. Other homework questions. There were a few others when I came around. I told you to remind me. 2-4, number 23. I heard a few people with this one actually, so let's take a look. Is that it, Natalie? All right. Is that the right? Yeah? All right, here we go. How do I start this problem, people? How do I start this problem? Remember, it's absolute value. So we can't touch the inside of the absolute value for now. We're solving it algebraically, not graphically or anything. How do I start this one? Francis. Say again? So, give me the first step. Yeah. Please don't do 7 minus 3 and put 4 out in front. The 3 is a coefficient of this whole expression. Make sure you don't subtract those numbers, please. It'd be very upsetting if I saw that. Again, this is attached. The 3 is attached here. You can't subtract those. So on the right-hand side, we got negative 3 now, right? But then what happens next? What do we do to get rid of the negative 3 out here? Yeah, so what does it end up becoming on the right-hand side, Summer? The right-hand side becomes just 1. Nice and loud, I can't hear you. Okay? And since we're dividing by a negative, flip the sign. Flip the direction of the sign. Okay? And now we're at the point where we can write our 2 different equations from here to solve algebraically. Let's go through that process. Remember, first of all, anybody can recognize right away, is this an AND or an OR statement? It's an AND statement because you have variable and absolute value less than some number. That's our indicator that's an AND, but we'll see that in a moment anyhow. But just to write it down as a note on the side. You should always do that, okay? It really will help you. So break this into two things. 4d minus 7 less than 1. You can shut that off now. It is definitely getting a little chilly. 4d minus 7 greater than or equal to negative 1. Yes, I am. Because we're not solving graphically, there's no need to get rid of it. It's more work than it helps.
So only if you're...
And when we're solving graphically, we want to have a coefficient of 1 in front of the variable term. So we do that. But here, it makes no difference. Go to this point, it makes it easier. Separate it, make one of them negative and flip the sign like we did, and then just solve them separately. Okay? Arthur.
So on the test, will you tell us how solve?
It'll say solve by any means, or it'll say solve algebraically, or it'll say solve graphically. It will definitely say it clearly. But no matter what, you're still going to have a graphical solution. Even if you solve algebraically, you can then graph on a number line. If you solve it on a number line, you can then write out the solution set. So either way, you're going to show the graphical solution and the algebraic solution. Okay? It'll say that in the directions. So add 7 over, divide by 4. Add 7 over, divide by 4. So d is less than 2, and it's or less than or equal to 2, and it's greater than 1.5, greater than or equal to 1.5. So where is d? Where is d?
In between 1.5 and 2.
Inclusively or exclusively?
Inclusively.
Why?
Because it's greater than or less than. I mean, greater than or equal to.
Yeah, because it's including the endpoints. How about that? It's inclusive. So it's between 1.5 and 2 inclusively because it's including the endpoints. How do I write this as a solution set? As a solution set. Who's got this for me?
D is in the set of, wait, 1.5 is less than D, which is less than 2. Less than or equal, which is less than
Good, very good. Less than or equal to. Okay? Now, you could also write this with the word and, if you really wanted to. You could say, D is greater than or equal to 1.5, and D is less than 2. But for an and statement, you're going to see it like this. And I'm telling you now that you'll have a multiple choice. And the answer might look like this, or it might have the word and in it. But you need to know that those are interchangeable, correct? Okay, you won't get both of those, obviously, because they'd both be right. But in your multiple choice, you can see it like this, or you can see these two expressions with the word and in between them. Either way works. So section 2.4, number 30.
It was no, it was 2.5.
2.5.
2.5. So a different section, hold on. That was 2.4, that last one. All right, 2.5, number 30. Section 2.5, number 30. Solve for x in terms of the other variables. Oh, nice. And this is the one with the generic solution. Good. A minus bx in absolute value is less than or equal to c. Agreed? That's the one? All right. What do I have to do to start this problem? Because I know some of you definitely got this. What do I do to start this? Dave, give me a starting point.
Switch the bx and the a.
And it doesn't matter because it's subtraction inside of the absolute value. It's the first first point to start with. Next, if b was a number, what would you do with it?
Take it out of the,
Factor it out. So what should you do with it?
factor it out.
So start by factoring out a b. If you take a b out of bx, what's left? Just x. Because again, redistribute. B times x is bx.
Wait, so this one is being subtracted.
Well, it's 2.5. It says, solve for x in terms of the other variables. Assume a, b, and c are positive numbers. This was under the graphical solution, so I would prefer to use a graphical solution here. I think it's easier. How would I get rid of what's with the a? If I take b out of a, what does it look like? A over b. And that's the confusing part. Remember what we did a little while ago when we had 4 over 3? Because we factored out a 3 out of both of these terms, but this happened to be a 4 and it became 4/3. It's the same thing again. If you take b out of a, you have to write it as a over b. Here's why. Redistribute this. When you redistribute here, the b's cancel, leaving behind just the a up top. So at this point, we can have this less than c, less than or equal to c. Divide by the absolute value of b. Now here, I cannot drop the absolute value here, which is weird. It really is weird. But you cannot drop your absolute value. Because think about this for a moment. What if b was negative? If b was negative 2 and I get rid of this absolute value, now I'm saying there's a negative 2 out front. But clearly it's the absolute value of that, right? So whatever b is, don't I want the positive value of it? Would everybody agree with me? Whatever b is, if b is negative, positive, anything, I want the positive value of it. So I can't get rid of the absolute value. So just divide by absolute value of b on both sides. But it gets rid of it that way. Okay?
It says b has to be positive, doesn't it?
Oh, I didn't know that. I'm sorry. Is that what you guys all raising your hand for?
Oh, I was asking if it was, let's just say they all had numbers and b was like -2 and you factored it out, could you just make it 2 and drop the absolute value?
Yes, exactly. Because you're pulling it out with absolute value. The directions do say that a, b, and c are positive constants. So technically I could drop the absolute value. I'm going to leave it though. Just for the heck of it. You would drop it, okay? But I'm going to leave it. Because it's the same process still. But I want you to think about what would happen really. Now, what's my starting point? What's my starting point? A over b. It's already minus, I don't have to worry. What's my deviation? What's my deviation?
C over
Absolute value b.
absolute value.
C over absolute value b. So go to your number line. Starting point. Okay? Then just go ahead and add and subtract the deviation. Okay? That's what it's going to look like. Now the reason the book tells you they're positive constants is so you can combine like terms here because you would have a common denominator of b. Does everybody see that? That's why they're doing that, just for your own knowledge. This happened to be a less than. Is that an and or an or? What did we say? And. So we're going to shade in between here. And it's closed circles because it's less than or equal to. Now, if I were to actually do this with B being positive, this would become A minus C all over B. This would become A plus C all over B. So if I wanted to do what the book said and think of B as positive, this becomes, and this becomes this. Because B would then be a common denominator, and you could add those fractions together. So these are our real endpoints. If we looked at B as a positive quantity. What would the solution set look like for x here? What would the solution set look like for x worth?
A minus C over B is less than or equal to x, and
Which is?
which is less than or equal to A plus C over B.
Very good. So in this problem, the reason they make A positive, again, a B positive, is to get rid of that absolute value, so you can simplify your fractions. Is this what the book gave you, I'm assuming, in these terms?
Pretty much.
Okay. Let's see, we have about a minute left. Can I quickly, or 2 minutes left, it's a B day, right? I would like to go over the format so you have an idea. I did this last time. It's shorter. You only have one period for shorts, only 4 pages. It's a lot shorter. The test will be worth 90 points instead of 100, just because it's less material, fewer days. So I do it proportionally, so it's fair. There will be 2 multiple choice problems to start. There will be 2 quick short answers, where I give you a graph and ask you to tell me what the solution set looks like from the graph and the number line. So if I gave you this number line, and I told you to give me the solution set, is that clear? Say you have to be able to write the solution set from the number line. You're going to have about 8 problems after that that are solving one of the above. Either basic inequalities that are combined, where you have things look like this, combined inequalities where it's 2 less thans, so or statements and statements, absolute value equations, and absolute value inequalities. So there'll be about 8 of those. That's from like section, I think it's like 2.1, 2.2, 2.3, and 2.4. Okay? Then I'm going to ask you to use a graphical method. Where did I put graphical? The 2 of these are graphical out of those 8, sorry. 2 of those are. Then there's going to be a problem where I'm going to ask you to write expressions from given statements like we did in 1.8 at the end there. So like, a number is twice another number, but divided by its square, something like that. You know? So 2x over x squared. Twice a number, but divided by its square. Something like that. You have a problem of that. And then you're going to have 4 word problems for you to choose 3 of. Okay, I'll give you some hints. Study the one we did with the calculator, with profit, where profit is equal to the income minus the cost. We had to sell a certain amount of calculators to make a profit. That's a good one to look at. We also did one in class with grades. Remember with grades, like Johnny has a grade between an 80 and 83. If his test scores are X plus 7, and X plus 25, determine what his first test might have been. We did one of those in class. Distance rate for sure. Absolutely, we did distance rate problem. And then most likely a coin problem is the 4th one, I think. I haven't come up with the 4th one yet. I'm thinking about that. So that'll be like a wild card. But that's pretty much the whole thing. Okay? It's a little bit shorter than the last test was, but you're definitely only going to have 1 period. So you need to be efficient and work quickly on the test. Don't waste time on the multiple choice if it's only 2 points. The word problems are worth like 8 or 9. Some of those long answer ones throughout the test, like the graphing of the absolute value stuff, they're worth like 6 or 7 each. So don't spend 10 minutes on each multiple choice. I saw a bunch of you spending all this time. They're 2 points each. Whenever I took a test as a kid, you know what I did? I found the most worthwhile problems and started there. Anything with the most points, I started there. So I get my best bang for my buck. Okay? Please, guys, please, think smart.